Alright, so today we are going to learn about radian measure. As most of you know, we've been working with degrees so far, and on our calculators we've had to often change it from degree or radian mode to degree mode. So on the calculator, the way that you change between modes is you press the mode key, and you can see the third option down. You can't really see too well on there. But the third option down, you can choose radians or degrees. For right now, we'll keep our calculators in degrees because we won't be using our calculators today, but that will help you in the future if you need to switch to radians. So we're going to first talk about angles in standard position. And in standard position, the initial side or the starting side is the side that's always fixed. It's where you start. And if we look at a coordinate plane here, it always starts on the positive x-axis with the origin being your vertex. The terminal side is the side that where you rotate to make the angle. If it rotates counterclockwise, meaning up towards the y-axis, it's a positive rotation, and if it rotates down towards the negative y-axis, it's a negative rotation. Okay. So down here, let's try a couple examples. So if I wanted to draw a 240 degree angle, I know 240 degrees comes in between 180 and 270. So I'm going to start in the positive y-axis and I'm going to rotate around so I'm between those two axes and draw my terminal side. And then I have an angle of 240 degrees. If I have an angle of 500 degrees, that's more than 360. So I'm going to do 360 plus 90 is going to give me 450, so I'm going to go 50 more. So I'm going to start on my initial side, the positive x-axis, and I'm going to rotate positively all the way around. That's 360. I'm then going to go back up to 90, and I will go 50 more, so a little bit closer to that next axis, and draw my terminal side. Notice that I went more than one time around the circle. For example number 3, I have negative 50 degrees, so again I'm going to start in the same position, but this time I'm going to go opposite in direction. So I'm not going to go all the way down to the what would be negative 90. I'm just going to go a little ways and then draw in my terminal side, and that's going to be negative 50. Okay? Now what we're learning today is we're learning a new way to describe angles. And so we have two ways now to measure angles. One is degrees, which we're pretty familiar with, where we start at the 0 degrees, 90 degrees, 180 degrees, 270 degrees, and back to 360 when you get all the way around the circle. The new way that we're introducing today is radians. There are 2 pi radians in a circle with radius r. We almost always work with circles with radius r. So we're going to start at 0, just like we did before, and when we get up to 90, we're now going to call it pi over 2 radians. 180 degrees is going to be pi radians. 270 degrees is going to be 3 pi over 2 radians, and when we get all the way around the circle, it'll be 2 pi radians. Okay? Alright, so a lot we'll have to work with coterminal angles, and those are just angles whose terminal sides coincide. They end in the same spot. Coterminal angles can be found by adding or subtracting 360 degrees to angles that are given in degrees, or adding and subtracting 2 pi to an angle that's given in radians. We're going to try a couple examples here. So to find 2 coterminal angles with 240, we would take 240 degrees and add 360 degrees. We would get 600 degrees. If I wanted to find another one, I could add 360 again to get 960 degrees, and I could continue doing that to get positive angles. If I wanted to get a negative angle, I could do 240 minus 360 degrees, and that would give me negative 120 degrees. If I subtracted 360 again, I would get negative 480 degrees, giving me another coterminal angle. Now notice that my example only asked for 2, but I did list 4 coterminal angles just to show you that you could continue going in either direction. Example number 2 says find 2 coterminal angles with 3 pi over 4. This angle is given in radians, so what I want to do is I want to either add 2 pi or subtract 2 pi. So if I take 3 pi over 4 and I want to add 2 pi, this is a fraction. I need to get a common denominator. So I'm going to put my 2 pi over 1 over 1. I'm then going to switch my color so you can see what I'm doing. My common denominator is going to be 4, so I will multiply the 2 pi over 1 by 4 over 4. My new problem becomes 3 pi over 4 plus 8 pi over 4. And when I add the tops together, I get 11 pi, and the bottom stays the same, over 4. And that is my radian answer. Okay? I also need to find another angle, so I'm going to subtract 2 pi. So I would have the same problem, 3 pi over 4. This time I'm going to subtract 8 pi over 4, and I would end up with negative 5 pi over 4. Again, with radians, you could continue to add or subtract 2 pi multiple times depending on how many coterminal angles you were looking for. Now that we have 2 ways to measure angles, it's important to know how to convert between degrees and radians. Whenever we're converting, you want to take into consideration the part, which is the angle that you're talking about, in relationship to the whole circle. So keep in mind, when we're talking about degrees, the whole circle is 360 degrees, and we're talking about radians, the whole circle is 2 pi degrees. I'm going to use this proportion every time I want to convert either degrees to radians or radians to degrees. So for my first example, I want to convert 125 degrees to radians. I'm going to put the 125 over 360 and set it equal to x over 2 pi. In order to solve this, I need to cross multiply. So when I cross multiply 2 pi times 125, I get 250 pi, and that's going to equal 360x. To solve this equation, I'm going to divide by 360. I need to reduce these so the zeros easily cancel out, and my answer is 25 pi over 36. I can do the same thing if I'm taking a radians and converting it to degrees. So I'm going to put my x in place of degrees this time and put it over 360. And I'm going to put negative pi over 12 and put that over 2 pi. This time when I cross multiply, I get 2 pi x is equal to negative 360 pi over 12. The negative 360 divided by 12 is really 30 pi. So I'm going to get 2 pi x is equal to negative 30 pi. Now to get x by itself, I'm going to divide by 2 pi, and I get x is equal to negative 15 degrees. Notice the pi's cancel out and I just get negative 30 divided by 2. And there's my answer. Okay. In addition to converting and finding coterminal angles, we have many common degrees and radians of special angles that we'll be working with. So if you take a look at these, here we have angles in 30-degree increments with their radian measures. So 30 degrees is equal to pi over 6, 60 is equal to pi over 3, 90 is equal to pi over 2, 120 is equal to 2 pi over 3, 150, 5 pi over 6, and so forth. Now, if you had to recreate this circle, the way that I do is I say we're in terms of denominators of 6. So this is like 1 pi over 6. This is equivalent to 2 pi over 6. This is equivalent to 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So it goes up by 1 each time. These that I wrote here are just reduced. The same is true for the 45-degree increment circle. I start at 0, and 45 degrees is equal to pi over 4. 90 is pi over 2 again. 135 is 3 pi over 4, and 180 is pi, and so on and so forth. This circle can be made in the same way. This is 1 pi over 4. This is equivalent to 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, equivalent to 6 pi over 4, 7 pi over 4, and equivalent to 8 pi over 4. Thank you and have a great day.